sometimes it's a little bit, well, it takes a little bit too much time to maintain tests. So for example, if you change production code and then you have to change your test, that this is kind of unproductive, that this kind of like takes too much time. Hope you think so. Hands up. Okay. So let's see. We're gonna change that hopefully in that session. So hi, I'm very welcome. I'm very happy to be here. My name is Sebastian. I'm a Java EE consultant, author, and trainer. I'm a book author, and last year I wrote a book on modern Java EE applications. I'm from Germany, so I'm German, and this is my second trip actually to India. I've been in India last year, and now this is the first time to Bangalore, and I'm very happy to be here. So this is a little bit about myself. I do a lot of Java enterprise things, a lot of enterprise development, and I help companies to improve their enterprise technology. That is my book that I wrote last year about architecting modern Java EE applications, well, how to write Java EE applications in a somewhat modern way, and to show that it's indeed possible to write modern Java EE. And a few more things about myself, so don't worry, there won't be too much slides here. I do some consultant work, some workshops and training for enterprises on topics like this. For example, for enterprise testing, how to do that in an effective way. You can visit my website if you like. And what about testing applications? So just a few things in advance. There is some kind of testing pyramid, if you know that, so about unit tests and integration tests, end-to-end tests, and so on and so forth. And first of all, what I want to focus on are end-to-end tests. That means testing an application that is running in ideally the same way as it would run in production, and testing our business logic there, whether that application behaves in that way as expected, right? So we will not focus on unit testing or component tests, like testing a single component, whatever that is, single class, or a couple of coherent components. No, we want to test our application in the same way as it would run in production for a couple of reasons. And I want to focus on that first, and I want to show you how that is possible in an effective way, and especially if you use containers such as Docker and container orchestration such as Kubernetes, because how these technologies will help you there, doing all the setup, doing the definitions of how your environment looks like, and help you to construct these tests in a maintainable way. All right, so what I have here is an application that is deployed to a Kubernetes cluster, or actually two applications, that is called Coffee Shop. So maybe you know I like coffee. So this is a Java EE application, Java E7 application, actually two of them, that will run in a Kubernetes cluster. That cluster doesn't actually matter, but we have two applications, and we are writing that Coffee Shop application, or actually I already wrote it, and now we want to test that from an end-to-end perspective. And how that looks like is that we have our Coffee Shop application that talks internally to a database, and a user connects to that application via HTTP. All right. And now this would be a little bit too simple, because then what we would do to test that, we write an external test. In that test, we connect via HTTP to that application, see what it does, see what the response looks like, and that's it. To make that a little bit more complicated, that application should now also communicate with a second application, right? And that second application actually will be communicated with in an asynchronous way. So not immediately, otherwise that would also be kind of easier to test. We send a request, afterwards we get a response, and then the second system will be involved. But now this will be done in an asynchronous way. So actually we have a so-called coffee processor that we'll talk to in an asynchronous way. So what we do is, as a user, we create some coffee orders. We want to order a new coffee at our coffee shop, right? And then it takes some time to make that coffee. And there is a second system involved that is called the coffee processor, and that will process our coffee asynchronously. So the user actually afterwards have to come back and then ask for the coffee. Now this creates a certain challenge for the test, because then, we have to test if the asynchronicity works, right? If that system later on was called in a correct way, the second system. So this is what we want to test, right? And any questions, by the way? If you have any questions, anytime, just feel free to ask. Otherwise, I'll show you just briefly some code, some quick walkthrough to that. That is the first application. We only will have a look at that application that we want to test. So like in unit tests, we focus on one unit, one class mostly. Everything else will be marked away. Similarly, we now want to test our coffee shop example. Not anything else, but our coffee shop application, how it would run as it would run like in production later on. In order to do that, there is the coffee shop project, and it's a little bit small, but I can show you. Let's start from the JAX-RS resource. So actually we have a JAX-RS application, so there will be an HTTP endpoint that is called resources here, and we have a boundary where we can, well, order some coffee. So we can post some JSON to an orders resource and so on and so forth, and ultimately there is a resource here, resource method, so we can create a coffee order, and then we have a coffee shop, well, that orders some coffee. That saves the order to a database and done. The user can come back later. And now the asynchronous approach is that later on, at some point, that coffee order will be sent to the coffee processor system, right, in asynchronous way. We don't know how that works as a user. We don't see it. We just get the immediate response. But if we come back later using the same URI, we will see an update. And now this is what we want to test, whether actually, first of all, we can create that coffee order in the system using the same HTTP approach as we would do using a client. And then later on, we also want to see that the whole update process works, so that the order actually was sent to the coffee processor system. And now the reason why we want to test that using an end-to-end test first, or why I want to focus on these end-to-end tests first, is if we would test that using a unit test, or let's say some kind of integration component test on a code level, this is fine to test some business logic, but ultimately doing that, we're not sure if our application works then in production, right? For example, if we change something here in the JAX-RS resource, I do something with the post, or I require some HTTP header, or I change the JSON schema, whatever, then still my unit test or my component test would pass through. But if I deploy it then to production, well, that test fails. Because something, even if it's just a tiny, small change, doesn't work anymore. If a client wants to connect using HTTP, if a client wants to send this and that JSON data, well, then it doesn't work. And this is also the reason why I always tell companies, if you can, test the same thing, the exact same thing that runs in production in your test environment, because if that test passes and you've done everything right, then it will work in production, because there are no changes. If there are some changes in the configuration, the changes in the code that will run, the changes in what you actually test, well, then you can't really be sure. And now, image, the container in the test environment is the same image, and nothing can change, right? And if that is the case, well, then we're pretty sure that it will run and it will work later on in production. So actually how that works is, we have a Kubernetes cluster here, and these two services, let's call them, then are basically abstracted by so-called Kubernetes services. So what that is we have a coffee shop, our application, that then talks to, well, something that is a service. It looks like basically a DNS. So internally it does a DNS resolution. We talk to a logical name, a nicely readable coffee processor name. And internally in the cluster, well, that will route to my Docker container that is running there, which is fine. Because what we're doing then in the test, in the system test, is we basically swap that out. So if you think of unit tests and component tests, we test one unit, and that unit will talk to a mock, right? Such as Mockito or something like that, right? And now on a system test level, we can fire up a mock server instead that just acts as if it were the external system, but then we can control it within the system test. We can see if the correct response and a request was sent there, and so on and so forth. So how that looks like in the code is as follows, that now we have an order processor that is basically a managed bean that will, well, communicate with the external system, with the coffee shop processor that was there before. So what it does an HTTP connection to just, and this is the nice story about the Kubernetes environment, about the container orchestration, just the logical name coffee processor. And whatever that is depends on the environment. On production, it will be the coffee processor, that is the production coffee processor. On my system test environment, that will be the coffee processor, which is my mock server. And I don't have to change or reconfigure my application, which is a really nice way how that integrates. So I always talk to a coffee processor. I don't know what is running, but I don't care because right now I only want to test my coffee shop example application. Well, and this is then how it connects to the external system. That then responds, and then if that, for example, it does here order processing, if then updates the store status and saves that to the database, well, it has the new status of my order in place. How that looks like now is I have a Docker file. So basically what I do, I build up my application. Let's do this in a second. So I have this project running here. And since this is a Maven project, I can do a Maven build, a Maven clean package, for example. Oh, very good. I'm in the wrong project. I should do the coffee shop. This was not a Maven project. Maven clean package, and then it will build my coffee shop application, and ultimately I have a thin WAR file that will be placed in the Docker image. So how that looks like is I have a base image that now is a private registry of my own that comes with Wildfly. I use Wildfly here, but for that simple example, it actually doesn't matter. And then in a thin deployment approach, I only add my WAR file, the coffee shop WAR file, and then that's it. So let's do this. I do a Docker build, right? With my Docker container, I call this like that, coffee shop. And then I have, well, a lot of them, as you can see. I will use the version 1, Docker tag 1, and then it will just build that. It's super fast because it's a thin WAR file approach. So actually my WAR file is very small. It has like 26 kilobytes. So I built that. And then I have to push it. That means it will end up at my registry, otherwise I can't access it. And I hope now the Wi-Fi works. Yes. Very good question. If I created a very new image, why is there something that was already there before? Well, that comes from the base image here. Docker image, Docker file, I only have 2 steps, right? That results in 2 layers, which is not true because the base image actually also contains of a couple of steps. So what you just saw of all these layers, actually these layers already come from the base image. So that was the base image. That has been transmitted before. That wasn't changed. That comes from the company or something else. And now my own image, what I just did is I added one more layer. That is this line. I just copied my WAR file as well. This is a new layer, and that's sufficient for my cases. So I have my whole application in one thin WAR file that only contains my business code, my compiled Java classes. That will be added. Then I built a new Docker image for this. By the way, all the layers before already exist, so they don't have to be rebuilt. They don't have to be retransmit. That's good. It saves a lot of time. And when I push it, only that what changed will be retransmit. So this is why only you see that has been pushed. If I do this again, then already everything will be on my server, and it says already exists, done, even faster. If I rebuild it, well, then again, the latest layer will change. And now, if I want to run this in my environment, again, I could run this locally, but then locally I would have to set up that external system as well, right? Because my Docker container wants to communicate with something that is called coffee processor. So a better idea in this case is to let it run in a Kubernetes environment. So I have a Kubernetes cluster installed here on my computer with Minikube. So that already contains something. Kube control get pods. Pods are basically, well, an abstraction around a container. So pod is more or less a running, well, one or more running Docker containers. And they are abstracted away by so-called services. So I have a service coffee shop, and I have a service coffee processor. These are my 2 systems. And then I also have running pods, running containers. These are the actual running workloads that run my coffee shop system and also the external coffee processor. So in order to show you how that was created is that I have some Kubernetes YAML files. Who of you has used Kubernetes before? Hands up. Okay, well, a few. So YAML files, these look like that, is the way how these Kubernetes resources, all the things you saw in the diagram before, are created. Basically, what I want to do is I have a Docker image and I want to run it, right? So I say I want to have a so-called pod, or here an abstraction, a deployment, that deploys so and so many instances, actually one replica of my application. I could say 2, and then it will fire up 2 Docker containers. That's it. And in order to access it, I will need a so-called service. And that service is actually the reason why I can do the lookup. If I look into the coffee processor, why I can do the lookup via DNS. You saw HTTP coffee processor, port 8080, this is exactly this. And that is the reason why then Kubernetes can, well, route this to different actual running workloads, and why I can swap this in a system test environment. So this is the nice story about that. And if I want to deploy that infrastructure as code, I just tell my cluster, hey, by the way, here's the YAML file, do it. I can do this, kube control apply. Just say everything you find in that YAML file, please apply it to the cluster. That's under deployment production. And it's already there, nothing changed, but it saw service coffee processor, okay, deployment ingress, service coffee shop, this is what you just saw, and the deployment as well. So we'll fire that up. If I look again, it's still running, so I can access it using, how does it look like? Yes. I can basically create a new coffee order with any REST client. So this is now the user. The user accesses the system to create a new order. I use curl using a local URI. This goes to my laptop, and it says, all right, work 201 created, a new resource has been created. By the way, it's under this location. So let's have a look into this location, also with curl. Let's print this. I have a new coffee that I just created. I wanted to have a new coffee order. I want to order an espresso with coffee beans that come from Colombia, that country. And now it has been finished. What is that? The status, that status is the one that changes. So I initially create that order, then it would be created. You didn't saw that because in the meantime, it was already, with the timer, it was already asynchronously talking to the external system. So if I ask again, oh, now it's already collected. So how the status is, I first create a coffee order, then it will be finished at some point, and then if the client, the coffee drinker, collects the coffee, then it will be collected. And this is now to see that the external system, that the communication works. Because how the status is updated is by asking the external system. So now we can see that it works. But of course, we do not trust this. This is manual work. This was now a manual test, right? I created a new order and I saw, okay, what does it work using this JSON that I just fired up, using origin, Colombia, type espresso, and so on and so forth. This was a manual test. I fired that JSON against my application, and now I saw what the response is, but I want to do that in an automated way, including waiting for the external system. So actually what I want to do is that I want to fire up that system test. I want to create a test that connects to my coffee shop example application that I just did using curl, but in an automated way. And then it will talk to a mock server, so not the actual production system that I just talked to, but the mock server that is running in a system test environment. And now, that's the interesting thing, using the system test, I can then, similar to unit test, I then can control the mock server. I can say, now please respond in that way, now please respond in this way, now say finished, now say collected, now say that status for this response, and so on and so forth. Similar to a mock on a unit test level, I can now do this on a system test level. And how that works is, just briefly, I write a system test. And usually, let me close that, I write them in a separate project because I want to access the system from the outside. I do not want to reuse any existing production code because then I change code on both sides and I don't see if a test breaks because I did some changes, for example, in the resource, and then I don't know that my test actually should have breaked if the client still connects using the old approach. So actually what I have is I have a coffee order system test, which is still empty. So I would just create that right now. By doing so, I want to show you how I usually create tests, because this is very important. Who of you uses copy and paste to maintain existing tests? Hands up. Who of you has used, you have a test case, oh, this is how it looks like, copy and paste. Change 3 things, okay. And now a new test case, paste it again, change 3 things, and now if some functionality changes, that's bad, because you have to change a lot of places, all of the copy and paste places where you inserted that code, and this is exactly the reason why we have non-maintainable tests, right? This is exactly the reason why most developers don't like testing, because it's annoying. I change something in the production code, like 5 minutes, and now I spend 2 hours maintaining my test with all the copy and paste. That's, no, bad idea. Yes, question?
What's the IDE?
The IDE, that's Intellij. It's Intellij with a very big font and a Vim, actually, inclusion. So let's say, I'm using JUnit 5 here. I have one test case, create, verify, order. So what I want to do is I want to create an order, and I want to verify if that works. Same thing like I did in curl, right? I create a new order from the outside using HTTP, and then I want to verify if it has been created. Now, if I would say, and I'm deliberately writing in comments first, I'm not writing any code. First of all, that's creative brain work. I don't want to implement it yet. I want to think about what do I want to test? Which coffee order do I want to create? I have HTTP 200 OK, and so on and so forth. What is the difference? The second example is way too low level information. I don't care about that. If I construct my test scenarios, I really want to ask myself, what am I going to test? I'm going to create a new coffee order, and then I'm going to verify if that coffee order has this and that information. However that is created is a different story, and that will be a different concern that will be crafted using a different delegate, a different component where my information will be contained. Because what happens, if I create that example using code that sends some HTTP, does some post, does some HTTP status checking, now my protocol changes from HTTP to something else. Or my JSON format changes, and I have hundreds of lines where I write JSON, origin, something like that. Not maintainable, bad idea. And it violates the single point of responsibility principle. And this is ultimately what I'm talking about. You have to take code quality concerns into account if you're writing test code. And this is very important, because mostly people say, oh, it's just test code. Copy-paste, doesn't matter, right? This will not run in production. It doesn't really matter if you have a high code quality. It does matter, because you will have to change that test code, and it should be maintainable. So this is why you should start with, having in mind what you actually want to test, and this is why I advise people to start with, even on paper, start with the rough idea first. Start with comments, and then implement, what you actually want to test. And what you can do then is, and this is not forbidden, this is actually a good idea, to write delegates here. Create another class in your test scope that is, for example, a coffee order system. And that will include all the methods that actually implement this. So then you're just calling methods, create an order. However you do that, different story, that can change. I don't care here, this is my test scenario. The test scenario just says, create an order with the following information. Then verify the order with the following information, and so on and so forth. And now the other component will actually implement it. There, it will be coded how to do it, how to do the HTTP lookup, and so on and so forth. And I created something already for you. So let's do some, oops, what's that? some implementation where I included two delegates that I call coffee order system and processor system. What is that? These are two other classes in my test scope that now include that functionality, how I want to test this, how I want to implement, how I create, for example, a coffee order. And then as you can see, this is now the implementation of my first test scenario, not how it is done on the lower level, but how I want the test scenario to test. I create a coffee order, an espresso from Colombia, and then I say, coffee order system, please create an order, however you do that. And now, well, you should take into to consideration that you don't craft any leaky abstractions. So here, I don't care about HTTP. I don't want to know about HTTP. The only thing I have, well, here is a URI. This is basically the identification of my coffee order. This is fine that this is a URI. I get the URI back, and then it says, okay, well, please load now the order with that URI. So access the system and verify if all the information is correct, right? So what it does, it accesses the first system again using the second component. And then I check, well, if all the information is correct. So basically, if the type matches and the origin matches, that is the actual test. And then also verify if now I have one more order. So it will access the coffee orders system first. It checks for the size of the coffee orders, and afterwards it will check that it has one more, right? Same story. If I want to create an order, and now this becomes more interesting. I now create an order, what I did before, using curl, and now I ask, well, does the processing work? So now internally, does my application communicate with the external system in a correct way? So I wait, I create the order, then I wait until the external system will be called. And this is now a little bit more difficult. So I create an order, such as I did before, fine. And now I tell my processor system, by the way, if any order comes in with that URI, then please respond in the following way. Because my external system, I will show you in a second how that's implemented, is now a mock server. This is not the actual system, this is now just a mock, and I will have to tell it how that works. So anyway, if that URI comes in, please respond accordingly. Please respond using that status. First status is preparing. Now the coffee order will be prepared, right? Then, by the way, I can verify again if the information was inserted correctly, all right? And now I will wait for the processing and load the order again. This is a private method, also not forbidden, actually a very good idea to craft some methods that implement your logic. It will tell the system now wait for the invocation. This is now required because I have this asynchronous processing, and I actually do want to wait until that has been called, including a timeout, of course. Otherwise, the test will run forever. But I want to make sure if that was called accordingly. And if so, then please ask the coffee order system again and return my coffee order, because now the status should be updated, right? And then we're here. We check for the preparing status. This is the second status. And then afterwards, this is the one you saw, we check whether it's been finished. And if all that works, then we can be sure that the communication with the second system works, because the status will only be updated if we can communicate accordingly, right? And I can show you now how that is implemented using the second system. That is the processor system. What it does, it uses wire mock. That is one implementation of such a mock on a system level to connect against my wire mock system that, runs under coffee processor in a test scope with my local Kubernetes cluster. I will fire that up in a second. And then it says, well, if somebody accesses, this is now the URI that my system will access. If somebody accesses that, please respond accordingly using that JSON. And that is then the information that my system expects to say, well, send something equal to, this is the order and this is the following status, and so on and so forth. That code is now wiremock code, so it will tell it basically, if that is requested using HTTP, then respond accordingly using that JSON in my case. Basically, it tells the system how to respond. And now the public method that I will call is this one, wait for invocation. It basically has a timeout. It will wait for 1 minute because this is now known to my system. I have to know how fast my system normally is. It has a timer for, I think it's 10 seconds. And then it will wait accordingly if you see extract ID, if something has been called using that URI. So if that URI has been requested, and also if that status was correct. Basically, it tells us, has my system been called correctly? Using the correct JSON and everything how you would expect it. And if that works, well, we can move on. And this is also how my component of my first system works. You probably already assumed that. This is basically what I did using curl, right? I access my first system. I use JAX-RS here because JAX-RS already ships with Java EE. It doesn't matter. You can use any HTTP client. Actually, all these tests can be constructed in any technology of your choice, right? Because they are system tests. They have nothing to do with your production code. They run externally. This is also important to mention. For example, I'm crafting orders here. That is a Java pojo that I will use to serialize the JSON. This is a different one, deliberately, than the production code. The production order looks as follows. It has, way more stuff in it. It has JPA mappings. I don't need that in my system test. Actually, I don't want to know in my system test if that's mapped using Java EE, using JPA, using something else. That's not part of the test. The application has to work in the correct way, however that is done, right? And also it has some proper types, for example, for the coffee type, which is an enum, and so on and so forth. In my test, that here doesn't matter also. I just sent some strings. That can totally be fine if the correct strings are sent back. So that can be simplified. All right, if all that works, then we can be sure that now the system works. This is basically an automated approach of what I showed using curl. So in order to test that, I have to see whether my system test is running. No, it's not running yet. These are all the pods that run on my Kubernetes cluster. You see there are not a lot of other so-called namespaces. So what I will do, I will now fire up my system test environment. How does it look like? Well, very similar to my production environment. The only difference is my processor. You saw the difference between here and there is, on the bottom, I use a mock instead of the correct system. So the system test environment looks exactly the same, but it's, of course, deployed to another namespace, so these two don't collide. And also, this is the same as if I would use another Kubernetes cluster, right? But I only have one, so I deploy both to the same using another namespace, but it doesn't matter. And that processor is almost the same, but it uses a different image. It actually is not the coffee processor image, it's a mock. That is a wire mock, same thing that I used in my code, and this will be communicated with using my system test. Having that said, I fire up the deployment for the system test, and then it will create all these things. It will now create, since I'm just firing that up, a new service, a new deployment, and so on and so forth for my system test scope. So if I now ask to give me the pods for my system test namespace, it will say, these things are running. They're not fully started up yet. This will take a second. And, in a couple of moments, hopefully my coffee shop and my coffee processor are up and running. And then I can connect to them using my end-to-end test. So what the end-to-end test is doing is, you already saw that here, it connects to, this is now the test scope of my Kubernetes cluster, to now that coffee shop in the test scope. And then it will fire up all these things. All right, now it's running and ready. That means I can fire up my test. So what it does, the application, the coffee shop application runs in the same way as it would run in production. And down there, it's a little bit small, but it's first of all running the first test, create verify order. So what it does, it will connect against, and that already was green. It will connect against the system. That is comparably fast because it connects against the system will store the status. I ask the system again for the status. If the status matches, fine. Now the second one takes longer. Why? Because actually I have to wait. I have to wait at least twice. I create this, the coffee order. I verify if the coffee order was correct. All right. Now, it waits for the second system to get the status, for the second system to be called by the first system, because this is what I actually want to test. It says wait as long as I get that request for, in this external system, right? And now I have a big JSON array, and I check, well, JSON object, I send that JSON via that post, and I see if I get status 201 created back, and I save the location, that is now this URI, and then I use that location to do an HTTP GET, and so on and so forth. Again and again and again. If then the URI changes, or if this JSON schema changes, it's a lot of work, and this is what makes tests so hard to maintain. In this case, it's easy to maintain. If I want to change some test scenario information, I do it here. If I want to say, do some cappuccino instead of the espresso, do it here, done. Nowhere else. That is just that test scenario. Or if I say even big changes like exchange HTTP against something else, some other communication format, doesn't matter, because there is an interface in that, well, not a Java interface, but that class, the interface doesn't contain any HTTP information. So I just say create an order for that POJO, and I get a URI back. Well, in this case, it will be the URI for the identification, but if, for example, I change JSON for XML for something else, if I change the HTTP information, the status codes, it's only in that class, and the tests are maintainable for me to edit. All right, just a very quick note on component tests. This is now another level of tests that I briefly introduced in, or not briefly, that I introduced in my book as well, for how to make code level tests also a little bit maintainable. Who of you has used JUnit together with Mockito? Hands up. Yeah, a lot of you. And you know, depending on how your Mockito setup looks like, it's either a little bit inflexible or a lot of work to do, right? You always have to write mock here, mock there, or you use annotations, but then the annotations don't always work with if you do some more complex dependency injection. So then not always the same beans are injected, and so on and so forth. So basically what I have this coffee shop, and this is not the system now, this is code level. So these are two classes, Java classes. I have the coffee shop class, that is now my boundary. That is basically the entry point for all my use cases. If I want to create an order, you see it's called here, and that will use, well, any other beans. So in order to write a component test, an integration test, code level test, if you like, I basically could, well, instantiate that class and then say, please do a mock on that system, right? On that order processor system. But that is a lot of work, and that, well, will be done for one test, and then I have to repeat myself all over again, so same story. How I solved that here is, or how I created that here is, now this is another project, this is not the system test project, but actually in my real code project, as I will use a so-called component test. What is basically, I have a coffee shop component that is now an extension of my class, of my coffee shop class. The same is true for my order shop processor, for the other managed bean. The reason why I'm doing that is so I will set up all the mocks and all the wiring, what would be the dependency injection, in my enhanced class, in my subclass. So that will extend the coffee shop bean, and it will, well, reset my dependencies using either a mock or another component that has been provided by the constructor. So actually I can now, and that's the idea behind component tests, I can now fire up a test scenario why I, let's say, want to instantiate that class as well, but for this class I use a mock. Or I instantiate all of these classes, and so on and so forth, depending on how your test scenario looks like. Because if you want to have a more complex scenario with a little bit of integration, more than just unit tests, then at some point, let's say, you want to set up all the classes, all the production code for the overall business use case, from the boundary down to all of the controls, or however you call them, but not for the external systems, not for the gateway, or not for the entity manager, stuff like that. So where you want to have fine control on which instances you want to create and which instances you will mock. And by doing so, this is, for example, the component for my order processor. This will mock all the JAX-RS instantiation here. You will, again, be more effective and more maintainable because now on these subclasses, you can introduce more methods. You can, for example, say, verify create order. This is, of course, test code. This is not in a production code. It matters. And this is already the most important thing. You want to construct and craft tension layers and separations of concerns, these principles. So this is what we've done, right? We created some code comments first or on paper, and then on a lower abstraction layer, in our case, on a different class, we implemented how we do things, right? Our test scenario is just like what we want to do, what we want to test. Reusable test components, like you saw, for example, for component tests or also for the system test scope, are very helpful as well. And in general, fast feedback, I always write this versus completeness. So this is very important to take into consideration. Of course, you want your test to run fast, but also you want your test to cover as much as possible. And this is the reason why I mostly advise to write end-to-end tests for systems that are already up and running, because these tests are usually very fast. If you use your system that is, for example, deployed by Kubernetes, you can deploy it very fast. And also, well, you just access your system. You don't have to fire up an embedded container, for example, all over again. You just use your system in a proper test scenario. And the last thing to mention, I didn't use any other test frameworks here than plain JUnit. And I know a lot of developers are big fans of Spark testing or Groovy or Scala test frameworks. And I'm not against to use these frameworks, although I didn't use them in that talk. But I just want to bonds, which is very helpful. But this is just the first very thin layer. If you have a lot of complex components in place, you need to craft them in order to be maintainable. This is what I did by creating a couple of classes, and this was just a simple example. So the more complex your business logic gets, from my experience, the more it matters that you have, well, proper test code quality. And the less it matters if for the very last layer, for your test scenario, you have nice frameworks in place or not. This is my opinion on that. But I can guarantee you, if you care about test code quality, then you will have more maintainable tests, and ultimately, it will be fun again to write test code. Thank you very much for your attention.